So this is the last section of new material for Chapter 2, and it's on number bases. And this might not be something you've ever seen before. It's not particularly hard, but it's probably going to be new. So the number system that we're working in is base 10. And I can tell that we're in base 10 because we use 10 distinct digits to represent any number possible. We have the numbers 0 and then 1 through 9. So there's 10 distinct digits. And in base 10, you expect to see 10 distinct digits. If I had a reason to use a different base, I'd have to have less or more digits depending on what the base is. If I had to work in base 4, then I should only have 4 digits that I'm allowed to use to create every single number. And those probably would be the numbers 0, 1, 2, and 3. Four distinct numbers. From those numbers, I'm going to create every number. Base 2, which is actually a common base to work with, is called the binary number system. And of course, if we're working in base 2, we're only allowed to have 2 digits, and those would be the numbers 0 and 1. This is a base that I even have some familiarity with. Back in the late 70s and early 80s, when I was in high school, we had the latest and greatest computer from Radio Shack at Thunderbird High School that had 4K of memory, 4,000 bits. I guess that means that we were allowed to use in it. We used to save our programs that we wrote on a cassette tape that you could play back on your car cassette player back in the day, and it make little beeps. But anyways, back in the day, computers worked in base 2. The code, the assembly language that worked for computers was working in base 2. This is because essentially back in the day, computers could only sense whether there was an electrical pulse or not. And I think if there was no electrical pulse, it was a 0. If there was an electrical pulse, there was a 1. So the language that they used to build the DOS system that used to run computers before Windows worked in base 2. And everything needed to be written with just 1s and 0s. We'll learn a little bit about base 2 in the future. Now, I'm pretty sure that computers, they work a heck of a lot faster now, and apparently working in base 10 wouldn't be something that would allow computers to get the same speed that they have now. Computers now usually work in base 16. Base 16, as opposed to being called binary, is called the hexadecimal system. And to work in base 16, computers need 16 distinct numbers to work with. And some of the numbers, because we kind of already have, we're not going to create new numbers. So some of the numbers are given symbols. In base 16, we have the 10 digits that we use in base 10. And then we have a number to stand for 11, which is A. B stands for 12. C stands for 13. D stands for 14. E stands for 15. And there shouldn't be an F there, because I guess there is. And F stands for 16. We'll say, I don't know that I actually did say that wrong. Ha ha ha. A stands for 10, B stands for 11, C for 12, D for 13, E for 14, and F for 15. You go up to one number lower than the base. So if you took some sort of machine or assembly language class now that's dealing with computers, my guess is you'd work it in base 16, and base 16 is not particularly fun to work with. I don't envision a lot of you working ever in base 16, and so we'll just focus on the easier bases, base 2 through base 10. I found some other things on the internet that I thought was interesting, just about different number bases, so I'll just kind of read through this. Historically, most but not all cultures have used base 10. The Yuki Indians of California used base 8 because they count the spaces between their fingers rather than the fingers themselves. The Babylonians used base 60, and the Mayans used a mix of base 20 and base 18. I'm sure I copied this from Wikipedia. I'm assuming that it's true. You can kind of read through this. I thought this was interesting. Abraham Lincoln's Gettysburg Address begins with 407 years ago. This means 87, and apparently that's base 20. So other bases are used, but realistically, we live in the world of base 10. Here's a little bit more on base 16. When I made up my web page, I had to pick the color of the fonts, and the computer program that I was using to make my web page, when you go to pick a color for a font, you define it by a letter name or a number / letter name in base 16. Apparently, on the program that I use, if I wanted to get white, I would type in all zeros. It would give me a white. If I want to get, the code for black is all zeros. The code for white, I don't remember this, is all Fs. And it just doesn't print so well, but that color, if you opened up my website, which is a purple color, that's the code for it. It's a base 16 number. So we're going to need to, in this section, be able to write numbers that are given in base 10 in other bases, and we need to take numbers in other bases and convert them to base 10. And it's going to be really important when we're working with numbers in bases to know powers of that base. So the first example I'm going to do is I'm going to take a number that's written in base 5. So I can tell that this number right here, 1403 base 5, is in base 5 because the 5 is subscripted. I have no sense for what that equals to, how big or small that number is, because in other bases it's not obvious. This is not 1403. It's probably less than 1403, but it could be bigger than 1403. So I want to convert this number that's in base 5 to base 10. Super easy to take a number in base 5 and write it in base 10. The first thing I'm going to do is I'm going to write the numbers backwards. So I'm going to write the 3 first, the 0 second. This is trying to accomplish my goal of writing the number 1403 base 10 base 5 into base 10. So I wrote the number backwards. Then I looked at the base 5 and I took each one of these numbers, 3, 0, 4, and 1, which is a number written backwards, and I multiplied each by a power of 5. So the 3 I multiplied by a power of 5, the 0 I multiplied by a power of 5, the 4 I multiplied by a power of 5, the 1 I multiplied by a power of 5, and the power of 5 that I multiply by, I start the first 5 with a power of 0, and then each subsequent 5 I add 1, so I went from 0 to 1 to 2 to 3. And then these individual products I need to add together. So to convert 1403 base 5 into base 10, first I write the number backwards. So instead of 1403, I write 3041. Then I multiply each one of those numbers, 3, 0, 4, and 1, by a power of 5, starting with the power of 0, ending with the last power, in this case 3. And I put plus signs between the numbers, and now I'm just going to figure out each. The first computation, I need to do exponents first, and anything to the 0 power is 1. So 3 times 5 to the 0 is equal to 3 times 1. I bring down the plus sign, and then I figure out what 5 to the first power is. 5 to the first power is 5. And then I do 5 squared and 5 cubed, all of which I have memorized, but you can use your calculator for. After I do the exponents, I do the multiplications. So the first multiplication I did was 3 times 1, and I got 3. The second multiplication I did was 0 times 5, and I got 0. Then I did 4 times 25 and got 100. And lastly, I did 1 times 125 and got 125. I added up these numbers. Apparently, they add up to 228. And this tells me that 1403 base 5 is equal to 228 base 10. Normally, when we write a number, we don't subscript the base, but there's an assumed subscripted base 10 when we're working in base 10. Just like there's a lot of numbers that we assume in algebra, the base 10 is an assumed number. Let me do one more of these and then we'll do some examples. This is a horrible example because there's so many numbers, but in base 2 it happens that we get a lot of numbers. So I want to change 101110 base 2 into base 10. Well, how do I do it? I write the number backwards. So writing the number backwards, I write, this 0 first, that 1 last. I just take these numbers and write them backwards. So I wrote 011101. So this 011101 is the number written backwards. So to convert from a base that's not base 10 into base 10, the first thing you do is you take your number and you write it backwards. And then next to each one of those numbers, you multiply by the base with an exponent. So I get 1 0, 3 1s, another 0, and a 1. And then, so I took the number, I wrote it backwards, multiplied each one of these numbers by the base, and then I attached exponents starting at 0 and incrementing up 1 each time. And then I put plus signs between. So this computation, which is much nicer, written more nicely down here, is exactly what I do. I wrote the number backwards, 011101, multiplied each of those numbers by a power of 2, gave each of the powers of 2 an exponent starting at 0 and working my way up till I was out of 2's. And then I put a plus sign between. If I was doing this, I would use my calculator to do the entire computations, and it would be simple to do on my calculator. I could just go 0 times 2 up arrow 0 plus 1 times 2 up arrow 1 plus 1 times 2 up arrow 2 plus 1 times 2 up arrow 3 exponent 3 plus 0 times 2 exponent 4 plus 1 times 2 exponent 5. When I hit enter, it's going to do the entire computation for me, and it's going to tell me that 101110 base 2 is equal to 46 base 10. So the first 20 problems, we're given numbers in alternate bases and we're asked to change them into base 10, and this should be friendly. It's the going backwards, given a number in base 10 and converting to another number, that's a little bit hard. So let's work on one together just in case I haven't done enough. So to do number 1, we're asked to convert 213 base 4 into base 10. How do I do that? I take the number and write it backwards. So I wrote 312. Next to each of the numbers, I'm going to put a times 4 because the base that we're starting with is 4. Now I'm going to give each of the 4's an exponent, starting with 0 and then going up by 1. And then I'm going to put plus signs between the terms. I have no desire to do this by hand, but you're more than welcome to do it by hand. By hand, what I would do would say this is 3 times 1 because 4 to the 0 power is 1, and 3 times 1 is 3. This is 1 times 4 because 4 to the first power is 4, and then 1 times 4 is 4. And then this is 2 times 16 because 4 squared is 16, and then 2 times 16 is 32. If I added these together, 3 plus 4 is 7 plus 32 is 39. This might be the only one I do by hand because I strongly prefer just doing it on my calculator because my calculator is not going to mess up like I'm going to mess up if I try to do them by hand. So by hand, 3 times 4 to the 0 plus 1 times 4 to the 1 plus 2 times, oops, we have to enter it right though, plus 2 times 4 squared, and I get 39. The answer to problem 1 is 213 base 4 is equal to 39 base 10. So let's do, you can do 3, I'll do 4 this time. For my number 4, I'm going to write the numbers backwards. I'm going to write a 1 then a 3. I'm going to multiply by 4 to the 0 and 4 to the 1, put a plus sign between, and then use my calculator. 1 times 4 to the 0 plus 3 times 4 to the 1. My answer for problem 4, 31 base 4 is equal to 13 base 10. Your problem 3, your answer should be 19 base 10. I'll do 5 with you. So I'm going to write the numbers backwards. I'm going to write 1, 1, 1, 0, 1. That's writing the number backwards. And I'm going to multiply each by a power of 2. I'm going to start with 0, sneak that plus sign in, bump the exponent on the 2 up to 1, put a plus sign in, bump the exponent up to 2, put a plus sign in, bump the exponent up to 3, put a plus sign in, bump the exponent up to 4, break out my calculator. 1 times 2 to the 0 plus 1 times 2 to the 1 plus 1 times 2 squared plus 0 times 2 cubed plus 1 times 2 to the 4th. And I get for problem 5, my answer is 23. I did more work than I have to do, because like this piece right here, I really didn't need to enter that. 0 times anything is 0. Had I not entered that, I still would have gotten 23 for an answer. And some of these exponents I could have done in my head, but sometimes when I do work in my head, I make mistakes. So the answer to 5 is 23. There's your problem 7. I'll do problem 8, so you can work on problem 7 and maybe not watch me do problem 8. You're going for 466 base 10. In case you need it, I'll do problem 8. For problem 8, I'm going to write a 4, a 3, a 2, and a 1. That's writing the numbers backwards. And then I multiply by 6 to the 0. Put my plus sign in. Multiply by 6 to the 1. Put my plus sign in. Multiply by 6 squared. Put my plus sign in. Multiplied by 6 cubed, and then calculator time. 4 times 6 to the 0 plus 3 times 6 to the 1 plus 2 times 6 squared plus 1 times 6 cubed, and for this problem I get 310, so the base 10. So 1, 2, 3, 4 base 6 is equal to 310 base 10, and again your problem 7 you're shooting for 466. Maybe we'll just do 2 more of these and then we'll go to the backwards way. I just feel like that's enough already. I'll do your number 9. You can pause the video and try to get the answer, so you don't have to watch me do this. For number 9, we're going for 108 base 10. For number 9, I'm going to write 3, 1, and 4. Write the number backwards. Then times 5 to the 0 plus 1 times 5 to the 1 plus 4 times 5 squared. No desire to do that by hand. I can definitely be more clever about pressing buttons on my calculator than I'm being. I could do some of the exponent works in my head, but I don't really need to. So I get 413 base 5 is equal to 108 base 10, and that matches up perfectly. Technically we have 1, 2, 3, I don't know, 4, 5 problems to do. This feels like overkill. Maybe we'll do 2 more and then we'll skip a few problems, and you can do 11. I'll do 12. When you do 11, you're shooting for 189. When I do 12, I'm going to write 5, 1, 2, 3, which is writing the number backwards, and then times 7 to the 0 plus times 7 to the 1 plus times 7 squared plus times 7 cubed. This is going to be a large number. So 5 times 7 to the 0 plus 1 times 7 to the 1 plus 2 times 7 squared plus 3 times 7 cubed. My answer, 3215 base 7 equals to 1139 base 10. Again, your answer for number 11 is 189 base 10. And then last problem, and then we'll go backwards, which is much, much harder. And I'll work through number 13 with you. So I'm going to write the number backwards. I'm going to write 1, 0, 1, 1, 1, and then times 2 to the 0 plus times 2 to the 1 plus times 2 squared plus times 2 cubed plus times 2 to the 4th. And if I don't mess up, I'm going to get 29 base 10 for my answer. So 1 times 2 to the 0, 1 times 2 to the 0. I'm not going to do the 0, I don't need it. Plus 1 times 2 squared, plus 1 times 2 cubed, plus 1 times 2 to the 4th. And I get that 29. So any piece that has a 0 is going to equal to 0, so you don't have to do that on your calculator. If you feel the urge and you want to do everything, here's problem 15. The answer to problem 15 is 146 base 10. Here's problem 17. The answer to problem 17 is 29 base 10. And there's problem 19. The answer to problem 19 is 139 base 10. Apparently, I don't know where problem 21 is because I must have deleted it. Oh, no. Oh, 21 actually has a base in it. Look at the answer to 21. It already has a base in it. So it's the answer to 21. I'm converting something in base 10 to base 5. It's 133 base 5. This is a little bit tricky. So I'll jump into it now, but this is the easy half. The next half is a little bit tricky, but it's not particularly hard. It's bound to be a hiccup in the video. The rest of the problems in section 2.6 give me a number in base 10, and they want me to convert it to an alternate base. My problem 22 gives me 56, and because there isn't a subscripted base, I'm assuming it's base 10, and I'm asked to convert it to base 5. When I initially recorded the video and wrote the material for this section, the way that I picked to solve the problem I thought was like the best way, the easiest way for students to understand. Discovered that was completely wrong, and the alternate method that I'm going to revert to now is the better way. So I'm not going to do the examples in my write-up because those were converting from base 10 to another base using a subtraction method, and that method just was confusing for students. So for each of the problems between 21 and 40, I'm going to do something that might not be consistent with my solutions manual right now, but I think it's the better way to do these. So in problems 1 through 20, when we took a number that wasn't a base other than 10 and converted it to base 10, basically we multiplied and added. To do problems 21 through 40, given a number in base 10 and convert it to an alternate base, I need to kind of do the opposite of multiplying and adding. And the opposite of multiplying and adding, in some sense, will be dividing and subtracting. So in order to do problems 21 through 40, I'm going to use a divide and subtract strategy. But I need to know what to divide by and then how to do the algorithm. So when I'm asked to convert to a specific base, I need to know the powers of that base, and I need every power of that base that is less than the number that I'm converting into that base. And so I'm going to start writing powers of 5, and I'm going to write them backwards because it's how I'm going to do the work. And if I have the problems written the right way, the power is written the right way, it's going to help me. So I have a fancy new calculator. I think it's going to show up better on the videos. So 5 to the 0 is the first power of 5 I need to consider. That's 1. It's less than 56. It's the number that I'm going to concern myself with. I'm going to move on to another power of 5, which is 5 to the first power. I'll do this on my calculator, but I hardly need to do it on my calculator. 5 to the first is 5. I need to find every power of 5 that's less than or equal to 56. When you do 21, you need to find every power of 5 that's less than or equal to 43. I'm going to move on to my next power of 5. 5 squared, which is 25. That's still less than or equal to 56, so I need to check one more. Once I get to a power of 5 that's bigger than 56, I'm going to ignore it and start doing the algorithm. So 5 cubed is 125. That's too big. So I found every power of 5 that's less than 25. These are going to be the same powers that you're going to use in your problem 21. Now I'm going to set up division problems for each of these powers of 5 in the order that I have them set up. So I'm going to divide by 25, or divide 25 into a number, and then I'm going to put a 5 outside my division bar, and then I'm going to put a 1 outside my division bar. And specifically, those are the 3 powers of 5 that are less than 56. You'll do exactly the same for problem 43. Your sketch is going to start like this. And then I'm going to work with the number that I was given. I was given 56. I'm going to now, on my calculator, divide 56 divided by 25 and look at the non-decimal part. The non-decimal part is 2. So I'm going to put a 2 on top my division bar. I'm just doing division, but I'm assuming that some of you are a little rusty, so I'm cheating and using my calculator to push me through that division. So I put a 2 on top of the division bar. Then I'm going to multiply 2 times 25. 2 times 25 is 50. I'm going to put a 50 under my division bar, and I'm going to subtract. 56 minus 50 gives me 6. I only have to do one step of the division. I'm not going to add a decimal and continue division. Once I get my remainder, I bring my remainder over to the next division bar, unless the remainder is less than the number outside the next division bar. We'll get to that a little bit later. This 6, that's the remainder, I put it under my next division bar. And then I ask myself, how many times does 5 go into 6? Or I can just simply do 6 divided by 5 and take the non-decimal part. I'll put a 1 on top of my division bar because I get a 1.2 and I don't want the decimal part. And then I'm going to multiply the 1 on top of the division bar by the 5 outside the division bar. 1 times 5 is 5. Just multiply, just generic division. Subtract, get a remainder of 1. Take my remainder, put it under the next bar, and then I divide 1 divided by 1. The 1 under the division bar divided by the 1 outside the division bar. I get 1 perfectly. Now I'm going to go 1 on top of the division bar times 1 under the division outside the division bar and get a 1. Subtract them and get a remainder of 0. Always on this last step I'm going to get a remainder of 0. And the answer to this is just going to be converting 56 to base 5. It's just going to be these numbers in order. In this case, it's going to be 211 base 5. I'm debating on going through 21 with you. Let me show the answer up here. 21 is 133 base 5. I'll let you try 21. And then of the next pair, 23 and 24, maybe I'll do 23 with you because it has a 0 in it, and I'm not sure my 24 does have a 0 in it. So give 21 a try. If you can't get it, I'll do 23 with you, then you should be able to come back and do it. So just to try to make your life a little bit nicer, let me do problem 23. I've done some preliminary work down here because I just wanted to save some time, but I'll pretend I hadn't done that. So what I'm going to do, if I want to change from 213 base 10 into base 3, is I want to start writing the powers of 3 going backwards. Some of them I could do in my head. Anything to the 0 power is 1, so 3 to the 0 is 1. Anything to the first power is itself. And I need to go until I get to a number that's bigger than 213. Let me just bop out the next few. 3 squared is 9. And then 3 cubed is 27. And then 3 to the 4th is 81. And I think the next one's going to be my too big. My 3 to the 5th is 243. And I need to find every power of 3 that's less than or equal to 213. And once I get to a number bigger than 213, I'm going to ignore that number and start my process. So my process is going to have 4 divisions. I'm going to have an 81 outside my division bar, a 27 outside my division bar, a 9, 3, and a 1 outside my division bar. And I need to put a number on top of each one of these division bars because my final answer has to have 1, 2, 3, 4, 5 digits in it because there's 5 powers of 3 that are less than 213. First number I put under my division bar is the 213. And then I just like to be lazy. I don't want to think so much. I can do the long division by hand, but I don't have to. I'm just going to do 213 divided by 81. Take the non-decimal part, which is the 2. Then I'm going to multiply the 2 times 81. Put it under my division bar and subtract. I'm going to go 213 minus 162. Gives me a remainder of 51. I only have to do one step on each division, so I'll be done with this, move on to the next one. Take the remainder of 51. If 51 was less than this number, eventually we'll get to that, I'd skip this, but it's bigger than 27, so I'm going to do that. Put a 51, the remainder, under my division bar. Now divide 51 divided by 27. So 51 divided by 27 is 1 point something. I'm going to put the 1 on there and ignore the point. Then I'm going to multiply the 1 that's on top of the division bar by the 27 that's outside the division bar, and get 1 times 27 is 27. And then I'm going to subtract 51 minus 27 is 24. That's my remainder. I'm going to bring my remainder over and put it under the next division bar. And then if you can do long division by hand, do it by hand. Pretend that you can't. I'm going to go 24 divided by 9. I get 2.6 something. I take the decimal part. Now I'm going to multiply 2 times 9 and get 18. I want to subtract that 18. 24 minus 18 is going to give me 6. Take the remainder of 6, put it under the next division bar. This I can do in my head. 3 goes into 6 2 times, so I'm going to put a 2 on top. But I could have done 6 divided by 3. It tells me to put a 2 on top. Now I'm going to go 2 times 3 is 6. 6 minus 6 is 0. Once I get a remainder of 0, I don't need to go any farther in terms of doing more divisions, but I need to have a number on top of every division bar. And once I get to a 0, if there's more division bars, I just toss a 0 up on top of that division bar. So I would say the answer to problem 23 is 21220 base 3. Again, once you get a remainder of 0, you're done with the algorithm, but if there's divisions after it, you need to put zeros on top of those. So when I look at my answer, it came out perfectly, 21220 base 3. The next page is going to be good because base 2, you start getting lots and lots of zeros in your answers, and that's where this can get tricky. So I'm going to do 26, and you might be able to do already without me 25, but in order to do 26, to convert 53 base 10 to base 2, I need every power of 2 that's less than or equal to 53. 2 to the 0 is 1, 2 to the first is 2, 2 to the second power is 2 times 2, which is 4. And then maybe I'm getting into ones that you can't do in your head. So let me do 2 to the third power, which is 8. And then 2 to the fourth power, which is 16. 2 to the fifth power, which is 32. And then 2 to the sixth power is too big, it's 64. When you're doing your problem, you're going to have a space for that 2 to the sixth power. For me, I don't need to include the 2 to the sixth power computation because it's bigger than my 53. And you're 25, you need to have a 2 to the sixth power, but you're not going to have a 2 to the seventh power. So when you go to do your problem 25, you're going to have one more division than me. You're going to have that initial division by 64. But I don't need that one, so I'm going to do all my divisions. I'm going to divide by 32. I'm going to divide by 16. I'm going to divide by 8. I'm going to divide by 4. I'm going to divide by 2. Just wrenching out of room here, and then I'm going to divide by 1. The number I'm going to put under my first division bar is the 53. I'm going to divide 53 by 32. And take the part that's not the decimal, so I'm going to go 1. Then I'm going to go 1 times 32. I could do that in my head. And then I'm going to subtract 53 minus 32 and get 21. 21, since it's bigger than 16, I'll put it under this division bar and do my next division. 21 divided by 16 is 1 point something. I'll put a 1 on top. Then I'm going to go 1 times 16 is 16. Subtract that 16 and go 21 minus 16 and get 5. Here's where the trick comes in. If your remainder is smaller than this number, you need to skip this. So I'm going to skip this one, because if I put a 5 under here and did the division, 5 divided by 8, it would tell me to put a 0 on top of the division bar, because I don't do the decimal part. So I'd put a 0 on top of the division bar, and I'd keep the 5 and take it to the next one. So if the remainder is less than the number outside the division bar, skip that division, put a 0 on top of that division, and move on to the next division. So I really shouldn't have even shown this. My remainder of 5 was less than that division. I put a 0 on, because if you divided 5 divided by 8, it would tell you to put a 0 on top of the division bar. Move on to the next division. Now I'm going to do 5 divided by 4, and 5 divided by 4 is going to be 1 point something. I'll put a 1 up top. Then I'm going to go 1 times 4 is 4. I'm going to subtract that 4 and get 5 minus 4 is 1. I'd like to put a 1 under this one, but it's smaller. And anytime I have a remainder, if it's smaller than the number outside the next division bar, you skip that step, put a 0 on top, and then carry that number onto the next unused division bar. And the last one, I'm going to go 1 divided by 1. 1 under the division bar divided by 1 outside the division bar. I'm going to get 1. Well, if I could actually do that right. So, delete. And now I'm going to subtract 1 minus 1 is 0. You always get to a 0. If you don't get to a 0 at some point, then you've messed up. So my answer for 26 is going to be 11010, and I'm changing the base 2, so I'm going to subscript a 2. So if you want to give your 25 a go, yours should be 1001001 base 2. Just in case you're struggling with base 2, let me do 37 on this sheet. And the nice thing about 37, it's in base 2. I need all the powers for 27, all the powers of base 2, all the powers of 2 that are less than 37. It's exactly these same numbers, because if I was doing problem 27 and I hadn't already done a base 2, I'd write all the powers of 2 and stop when I get to a power of 2 that's bigger than the number that I'm changing, which is 37 here. So I'm going to write all the powers of 2 less than 37. So I'm going to start and have a 32 outside my division bar, a 16 outside my division bar. I should not leave myself so much room. An 8 outside my division bar, a 4 outside my division bar, a 2 outside my division bar, and a 1 outside my division bar. I'm going to take the number that I'm given in problem 27 and write it under the first division, and then I can divide. You can use my calculator. I imagine most of you could do this in your head, but I'm going to go 37 divided by 32. I'll get a number. I'll take the non-decimal part, which is 1, and then I'm going to multiply. 1 times 32 is 32. And then I'm going to subtract 37 minus 32 and get 5. This is tricky because I have to look at the numbers that are out front, and my remainder of 5 is less than 16, so I skip this step. I'd like to throw my 5 under this division bar, but 5 is less than 8, so I skip this step, and when I skip, I put a 0 on top. Finally, on this division, I can put a 5. So the number that I only put a number under a division bar if it's less than or equal to the number outside the division bar. I skip anytime the number that I want to put under the division bar is less than the number outside the division bar, because if I had put the 5 under here, I would have done 5 divided by 16 on my calculator, got a 0 point something. It would have told me to put a 0 up on top of the division bar anyways. This I think I could do in my head. 4 goes into 5 one time. 1 times 4 is 4. I'm going to subtract 4, get a remainder of 1. I'd like to put the 1 under that division bar, but I can't because it's too small. 1 is less than 2, and anytime my remainder is less than the number outside the division bar, I skip that division and carry it over to the next one. I'm going to carry it over to the last one and go 1 divided by 1 is 1, and then I'm going to multiply. 1 times 1 is 1. Subtract. You always at some point should get a remainder of 0. Once you get a remainder of 0, you're essentially done. If there's divisions left, you throw zeros on top of it. So for 27, my answer is going to be 1, 0, 0, 1, 0, 1, base 2. And since I have the answer here, 27 is 1, 0, 0, 1, 0, 1, base 2. So perfection. For 29, you're working with base 4. I did some work down here for you. In fact, I did it on all the problems, but kind of been covering it up. When you're working with your problem 29, I did all the powers of 4 for you. 4 to the 5th is too big, so you're going to have to, when you do problem 29, have a division for 256, which is the biggest power of 4 that's less than or equal to 313. You're going to have a division of 64, a division of 16, a division of 4, and a division of 1. Mine's a little bit nicer. I'm going to do problem 30. I'm going to change 72 to base 5. So I needed all the powers of 5 that were less than or equal to 72. I did 5 to the 0, which is 1, 5 to the 1, which is 5, 5 squared, which is 25. 5 cubed was too big. I didn't really need to do it. So for my problem 30, I'm going to divide by, put 25 outside my division bar, 5 outside my division bar, and 1 outside my division bar. I'm going to take the 72, put it under, and I'm going to start off by going 72 divided by 25. Gives me 2 point something. I'll put a 2 up front. I'm going to multiply that 2 up top by the 25 that's under, or up front. And it'll go 2 times 25 is 50, and then 72 minus 50 is 22. Carry my remainder over. It's bigger than this 5, so I could throw it under here. I'll do 22 divided by 5, and I get 4 point something. I'll put a 4 on top my division bar. Now I'm going to go 4 times 5 is 20, and then subtract 22 minus 20 is 2. Take my remainder and put it under this division bar. Now I'm going to go 2 divided by 1 is 2, and then 2 times 1 is 2, 2 minus 2 is 0. My answer for number 30 is going to be 2, 4, 2, base 5. For your problem 29, the answer is going to be 1, 0, 3, 2, 1, base 4. Kind of getting worn out on doing these. Maybe I'll do 31 and 35 with you, just so if you need the help, and then let you do, I won't do all the evens. So pause the video and try to do 31 if you want to do it independently. If you're not ready to do it independently, then watch me do it. I'm going to do all the powers of 6 and stop when I get to something that's bigger than 49. 6 to the 0 is 1. 6 to the 1 is 6. 6 squared is 6 times 6, which is 36. And 6 cubed is 216. It's the one I'm not going to have to worry about. This is too big. So if I was doing problem 31, I wrote down all the powers of 6 that are less than or equal to 49. And now I'm going to do the 3 divisions that are going to be necessary. I'm going to put a 36, a 6, and a 1 outside my division bar. First number that goes under the division bar is the 49 base 10 that I'm starting with. Now I'm going to do 49 divided by 36, and I'm having issues here. 49 divided by 36, I get 1 point something. I put a 1 on top. And then I go 1 times 36 is 36. 49 minus 36 is 13. Carry my remainder over. I'd skip if it was less than 6, but since it's bigger than 6, I can do this. And now I'm going to go 13 divided by 6. I get 2 point something. I put a 2 on top of my division bar. Now I go 2 times 6 is 12. 13 minus 12 is 1. Carry my 1 over. 1 divided by 1 is 1. 1 times 1 is 1. 1 minus 1 is 0. For 31, my answer should be 121, and I'm changing the base 6, so base 6. Let me double check. Got the right answer. Feel good about it. Not going to do 32. And then on the next sheet for 33 and 34, just because I don't really think you need to see me do all of these, let you pause the video and try to get 33. The answer to 33 is 32033 base 5. I'll do that here in a second. And I did the preliminary work on my calculator. I did all the powers of 3 until I got to a number bigger than 2143. 3 to the 7th was too big. 3 to the 6th wasn't too big. So these are the divisions I'm going to need to worry about. I need a 729 out in front of my division bar, which is the biggest power of 3 that's less than or equal to 2143. And then a 243, an 81, a 27, a 9, a 3, and a 1. I didn't leave myself enough room. A 27, a 9, and then a 3, and a 1. So I didn't plan that so well. Let me do it down here. Try to write smaller. So 729, 243, 81, 27, 9, 3, and 1. The number I'm going to put under the division bar to start is 2143. This is where my calculator is going to come in handy. I'm going to go 2143 divided by 729. I get 2 point something. I take the 2 part. Don't worry about the point. Now I'm going to go 2 times 729 and get 1458. Then I'm going to subtract 2143 minus 1458. That gives me 685. 685 is bigger than this 243, so I'll put it under the 243. And now I'm going to do 685 divided by 243. I get 2 point something again, so I'll put a 2 up there. And then I'm going to go 2 times 243 and get 486. And then subtract 685 minus 486 and get 199. Carry that over, throw it under the 81. And now I'm going to do 199 divided by 81. I get another 2 point something. Multiply the 2 that I put on top by the 81 and get 162. Now 199 minus 162 and get 37. 37 is bigger than that 27, so I could sneak it under there. And now 37 divided by 27 gives me 1 point something, so I put a 1 on top. 1 times 27 is 27, and 37 minus 27 is 10. Take my 10 and put it under there. 9 goes into 10 one time. 1 times 9 is 9. 10 minus 9 is 1. And I finally get to my first skip. I shouldn't put a remainder under a division bar that has a bigger number than it out front. I should take it, skip it, put a 0 on top of that, and move it to the next one. So my remainder was less than that 3, so I skipped the 3, went to this final division. I'm going to do 1 divided by 1 and get 1, multiply, subtract, and get a remainder of 0. So I believe the answer to 33 is 2221101 base 5, and it doesn't look anything like the answer that I have written here. So this is beautiful that when I look at my answer here, it doesn't look anything like this. So this could be a mistake. How do I check my answer? Super easy to check. I do the process in reverse. So I'm going to try to check my answer. To check my answer, I'm going to change this number back to base 10. And how do I change it back to base 10? I write the number backwards, and I start multiplying by powers of 5, starting with 0. So I wrote the number 1, which is this number, and then the 0, which is that number, And for each one of these, I'm going to multiply by a power of 5. And go up 1 each time. So 1 times 5 to the 0, 0 times 5 to the 1, 1 times 5 squared, and then this one is going to be 1 times 5 cubed. This 2 is going to be 2 times 5 to the 4th. This 2 is going to be 2 times 5 to the 5th. And that 2 is going to be 2 times 5 to the 6th. So I need to do this computation, and if this computation equals 2143, then this answer is right and my key is wrong. So let me check it really quickly. So I'm going to go 1 times 5 to the 0 plus 0 times 5 to the 1. So I made a horrible mistake. I decided I was going to do 25, and I made a mistake, and I'm just redoing this problem. And it's going to be another glitch in my video. So how do I convert to base 5? Well, I need all the powers of 5 that are less than that number. 5 to the 0 is 1. 5 to the 1 is 5. 5 squared is 25. I have these memorized. You can do these on your calculator. 5 cubed is 125. 5 to the 4th is 625. And 5 to the 5th, I think, is too big. So as I go to do my powers of 5, the first power of 5 that's bigger than the number I'm worried about is 5 to the 5th. So I'm not going to worry about that. I'm going to do the division with 625 on the outside, 125 on the outside, 25 on the outside, 5 on the outside, and 1 on the outside. I'm going to take my 2143, put it under the first division bar, and now I'm going to divide 2143 divided by 625. Gives me 3 point something, so I put a 3 on top of my division bar. Now I'm going to go 3 times 625 and get 1875. I'm going to subtract 2143 minus 1875 and get 268. Carry it over. I'm allowed to put it under this one because it's bigger than the 125. Now I'm going to do 268 divided by 125 and get 2 point something. Put the 2 on top, ignore the point something, and then 2 times 125 and get 250. And then subtract 268 minus 250 and get 18. Anytime the number that you get is less than the number outside the next division bar, you skip that division bar. So I'm going to skip putting the 18 under there because 18 is less than the 25. Put a 0 on top of that division bar, bring the 18 over, and let me do this in my head. 5 goes into 18 3 times. 3 times 5 is 15. 18 minus 15 is 3. Bring my 3 over. 1 goes into 3 times. 3 times 1 is 3, and subtract and get a remainder of 0. I think the answer should be 32033 base 5. Let's pretend that I didn't have a key to look at and I wanted to check. How do I check? I check just like I would have done the problems in the beginning sections of the 1 through 20. I'd write the number backwards, so I'd write 3, 3, 0, 2, 3. Write the number backwards, and then multiply by each power of 5. Multiply each by a power of 5, and go up once each time. So the first 3, that 3 are multiplied by 5 to the 0, then 5 to the first, 5 to the second, 5 cubed, and 5 to the fourth. And then we put plus signs between. And I do one horrible computation on my calculator if I can get this to work out. My calculator is really fighting me with the glare right now. To check this on my calculator, I'm going to go 3 times 5 to the 0 plus 3 times 5 to the first plus 0 times 5 squared plus 2 times 5 cubed plus 3 times 5 to the fourth. So I wrote the number backwards. I multiplied each of the numbers by a power of 5, starting at 0, going up by 1, put a plus in between each. When I hit equals, it better equal to the number 2143 because that's what the starting number was, and it works out perfectly, so I know that this answer is correct. I'm going to leave you problems 35 and 37. I'm not going to go any further, but I'll help you out with problem 35. I'll write the answer down, and for you on problem 35, you should start at 4 cubed, and then go to 4 squared, and then 4 to the first, and 4 to the 0. The answer for problem 35, assuming my key is right, is 233 base 4. So you should try to do problem 35 with those numbers in mind for your division and that in mind for your answer. And then you should also try to do problem 37. And I hinted at that you should start at 2 to the 8th, which is 256, because 2 to the 9th is too big. So when you go to do 37, you're going to start with 2 to the 8th, which is 256. And then you'll have 2 to the 7th, which is 128. 2 to the 6th, which is 64. 2 to the 5th, which is 32. 2 to the 4th, which is 16. 2 cubed, which is 8. 2 squared, which is 4, 2 to the first power, which is 2, and 2 to the 0 power is 1. That's a ridiculous problem, but if you feel the motivation and you want to try that, those are all the numbers that go in front of the division bar, and that's going to be the answer for problem 37, assuming that it's correct. So I'm going to stop the video thinking that I've probably done enough that most of you can get through it, just to keep the video a little bit shorter than some of them have gotten.